right, so R10 talks about systems of equations. So there's two different ways that we can solve systems of equations. The first way we're going to look at is substitution. So solving a system of linear equations by substitution. Step one is to solve one of the equations for one of the variables. So it could either be x equals or y equals, but one of our equations has to be either just x equals or y equals. Step two is substitute the expression from step one in the other equation and solve for the other variable. So we're going to get like either x equals a number or y equals a number, and then we would take that number and plug it into the other equation to solve for our other variable. So let's look at number 1a. So we have to solve the system of linear equations by substitution. So step one is to have either x equals or y equals. Do I have that in A? Yeah, the first equation is y equals negative 2x minus 9. So y equals this. So what I'm going to do is take that and substitute it into y in the other equation. So that's getting plugged into y in the other equation. So I'm just taking the whole thing and plugging it into that y. So 6x minus 5. And now I'm taking negative 2x minus 9 and plugging that into y. So it's negative 2x minus 9 is equal to negative 19. So now in my new equation, I only have x's. So now I can just solve. So this is where we use stuff that we learned on Friday in R9. So how could I solve this equation for x? What can I do first? Multiply. So I'm going to distribute the negative 5 to both things inside the parentheses. So 6x, negative 5 times negative 2x becomes positive 10x. And then negative 5 times negative 9 would be positive 45 is equal to negative 19. So I distributed. What can I do next? Combine like terms. So when I have like terms on the same side of the equation, I just add them together. So 6x plus 10x would be 16x. What can I do next? Subtract 45. Perfect. I want my variable on one side and the numbers on the other. So I'm going to move that 45 to the other side. So I have negative 16x is equal to, what is negative 19 minus 45? 64. So negative 64. And then what's the last step I should do to solve for x? Divide by 16. So since x is being multiplied by 16, I divide it to move it to the other side. Now it's negative 64 divided by 16. Negative 4. So x equals negative 4. That's just one of our answers. I still have to find what y is equal to. So how do you think I could find y now? Take it and plug it into one of our two original equations. It doesn't matter which one. I'm going to plug it into the first one because the math looks like it'll be a little bit easier. So I have y is equal to negative 2 times negative 4 minus 9. So negative 2 times negative 4 would be what? Positive 8. And 8 minus 9? Negative 1. So y equals negative 1. So these are our two answers. We always write our answer as a coordinate pair. So it's always x, comma, y. So our x was negative 4 and our y is negative 1. So we would just write our answer like that. Right, so let's look at B. Step 1 is to get one of my equations to be either x equals or y equals. Do I have that here? Yeah, I have y equals 3x plus 14. So I'm going to take 3x plus 14, and what do I plug it into? I plug it into the y, because y equals 3x plus 14, so that gets substituted into the y. So I have 3x plus 14 is equal to negative 4x. So that y goes away, and we are substituting it in for 3x plus 14. So now I have an equation with just one variable. So I just want to solve for x. What can I do to solve for x? Instead of subtracting 14, what else could I do? I'm going to subtract 3x. So the reason why I picked 3x is because I already have an x on the other side. So I want to get my x's together and the constant on the other side. So 14 is equal to negative 7x. And then what can I do next? Divide by what? Divide by negative 7. So it's 14 divided by negative 7. Negative 2. So x is equal to negative 2. So that's one of our answers. I still have to find y. So what can I do to find y? Plug in negative 2 into x. It doesn't matter which equation. I'm going to plug it into the second one just because it looks easier. So I'm going to plug that into the x in my second equation. So I have y is equal to negative 4 times negative 2. So y is equal to what? Positive 8. And then how would I write my answer? Negative 2, comma 8. It's always x, then y. All right, let's look at C. So step 1 is to get either an x equals or y equals. Do I have that here? Yep, my second equation is y equals 1/2 x minus 1. So I'm going to take that 1/2 x minus 1 and plug it into what? I'm plugging it into the y. So I'm replacing that y and replacing it with 1/2 x minus 1. So I have 3x plus 2 times 1/2 x minus 1 is equal to 0. So now I have an equation just with one variable, so I'm going to solve for x. What can I do to solve for x? Distribute. So I'm going to distribute that 2. So 3x plus, what is 2 times 1/2 x? Perfect, 1. So just 1x, or just x. And then 2 times negative 1, negative 2 is equal to 0. What can I do next? Combine like terms. So since they're on the same side, I just add them together. So 3x plus x would be what? 4x. What can I do next? Add 2. So 4x is equal to 2. And then divide by 4. So x is equal to 1/2. Perfect. We have 2/4, but this simplifies. I can divide 2 by 2, and I can divide 4 by 2, so it becomes 1/2. So I found x. How can I find y? Plug it in. Which equation do you want to plug it into, the first or the second? Let's plug it into the second. Again, it doesn't matter. Sometimes one will look easier than the other, but you'll end up with the same answer. So I have y is equal to 1/2 times 1/2 minus 1. So just make sure whichever equation you plug it into, you are plugging it into x because it's x equals. So it does matter where you plug it in. You just have to make sure you're plugging it into the x. So now I'm solving for y. What can I do next? How do I solve? Well, I'm going to multiply. So how do I multiply fractions? Just multiply straight across. So 1 times 1 would be 1, and 2 times 2 is 4. So now I have 1/4 minus 1. How do I add or subtract fractions? I need a common denominator. So how can I make 1 have a common denominator of 4? I'm going to make it 1 over 1 and multiply the top and the bottom by 4. So now this is 1/4 minus 4 over 4. So I just changed 1 to be 4 over 4. So we just subtract the numerators and the denominator stays the same. So what's 1 minus 4? -3. And the denominator stays the same. So -3 over 4. And then how would I write my answer? One half comma -3 over 4. Perfect. It's always your x, then your y. All right, let's look at D. Step 1 is to get either x equals or y equals. Do I have that here? Yep. So I have x equals 6y minus 7. So what do I do with the 6y minus 7? I'm plugging it into x. So because it's x equals 6y minus 7, I'm plugging that into the x in my other equation. So I have 4 times 6y minus 7 plus y is equal to -3. And every time we plug it in, make sure you plug it in with parentheses. Because what do I have to do next? Distribute. So that 4 gets distributed to the 6y and the -7. So 4 times 6y is 24y, and 4 times -7, -28. What can I do next? Combine like terms. So I have 24y plus y. So what would that be? 25y minus 28 is equal to -3. What's next? Add 28 on both sides. So 25y is equal to, what is -3 plus 28? 25. And then the last step? Divide by 25. So what's 25 divided by 25? 1. So y equals 1. So that's just half of my answer. How do I find x? Plug 1 in for y. Do you want to plug it into the first equation or the second? Let's plug it into the first. So I'm plugging it into y. So I have x is equal to 6 times 1 minus 7. So first we multiply. 6 times 1 is just 6. And 6 minus 7, -1. So x is -1 and y is 1. How do I write my answer? -1, comma 1. It's always x, then your y. So sometimes we may not have like an x equals or y equals right off the bat, but we could always make our equation x equals. So let's say I had like x plus 2 is equal to 4y. How would I make this equation just x equals? Subtract 2. So x is equal to 4y minus 2. And then this would be what I substitute in. So if you don't have an x equals right off the bat or y equals, you could always make an x equals or y equals and then do substitution. So that's just an example. All right, next we're going to learn a new method. So we're going to be solving systems by elimination. So when solving systems by elimination, we're combining our like terms together, but we always need the same term. So it has to be a pair of like terms, but they have to have opposite coefficients. So if I have a 3x, that means I need a -3x to combine with it. So one of your variables is always going to be eliminated because you're going to have the same number but opposites. So it'll be the same number but opposites. meaning one will be a positive and one will be a negative. And that will be the variable that we eliminate. So let's look at A. Do I have the same variable that has the same number but opposites?
Yeah.
Which one?
2.
2y, a negative 2y. So I'm going to eliminate my y's. So when solving with the elimination, we combine our like terms together. So I'm going to add the x's. So what's 3x plus 3x? 6x. What is 2y minus 2y? 0. They cancel. So those get eliminated. And then I add the constants together. So what's 4 minus 4? 0. So now I have a new equation here, and I'm going to solve for x. So how would I solve for x? Divide by 6. So what's 0 divided by 6? 0. So x equals 0. How do you think I can solve for y? Plug it in. So x is 0. Do you want to plug it into the first equation or second? Let's plug it into the first. Again, it doesn't matter. Just make sure you're plugging it into x. So I have 3 times 0 plus 2y is equal to 4. So 3 times 0 is what? 0. So it just goes away. So I have 2y is equal to 4. What can I do next? Divide by 2. So y is equal to what? 2. 4 divided by 2 is 2. So now I have x and y. How would I write my answer? 0, 2. Let's look at B. Do I have the same number but opposites here? Yep, the x's. So my goal is to eliminate the x's first. So I'm going to combine all my like terms. 3x minus 3x cancels. What's 2y plus 4y? 6y. And 7 plus 5? 12. So now I can just solve for y. What do I need to do to solve for y? Divide by 6. So what does y equal? Y equals 2. So that's one answer. What can I do to find my other answer? Plug it into what? But make sure you plug it into y. So I have 3x plus 2 times 2 is equal to 7. So since it's y equals 2, I'm plugging that 2 into y. Now I'm going to solve for x. What do I do first? Multiply. So 3x plus 4 is equal to 7. What should I do next? Subtract 4. 3x is equal to what? 3. And then what's last? Divide by 3. So x equals what? 1. So how would I write my answer? 1, 2. Always x, y. So here again, we're going to solve by elimination. So looking at A. Do I have the same number but opposites? No. But I could make one of my variables the same number but opposites by multiplying something. So which variable do you want to make the same number but opposites, the x or the y's? I would probably say the y is going to be easier because what do I have to multiply to get my y's to cancel? I could just multiply the first equation by 2. You could multiply the second equation by -2 and then get the x's to cancel. So there's different ways to do this. If you wanted to cancel out the x's first, you could do that. Or you could cancel out the y's first. So I'm going to multiply my whole first equation by 2. So this becomes -20x plus 6y is equal to 2. So 10x gets multiplied to 2, 3y gets multiplied by 2, and 1 gets multiplied by 2. Everything in my first equation gets multiplied by 2. My second equation just stays the same, so that's negative 5x minus 6y is equal to 23. I just rewrote it right below so I can combine it a little bit easier. So now that I have the same variable but opposites, I can go ahead and eliminate them. So I'm going to combine all my like terms. What's negative 20x minus 5x? Negative 25x. What happens to the y's? They cancel. And then 2 plus 23? 25. What can I do next? Divide by negative 25. So x is equal to what? Negative 1. So I found half my answer. How do I find the other half? Plug it into x. Which equation do you want to plug it into? The second one? It doesn't matter. Just make sure you're plugging it into x. So I'm going to plug it into the second one. I have negative 5 times negative 1 minus 6y is equal to 23. What do I have to do first? Negative 5 times negative 1 would be 5. Minus 6y is equal to 23. What would I do next? Subtract 5. So negative 6y is equal to 23 minus 5, which is 18. And then what's last? Divide by negative 6. So what's 18 divided by negative 6? Negative 3. So I found x and I found y. How do I need to write my answer? Negative 1 comma negative 3. Perfect. All right, so we're solving with elimination. Do I have the same number but opposites here? No. So how can I make the same number but opposites? I can multiply the second equation by 3. So this whole thing is going to get multiplied by 3. So don't forget, everything here gets multiplied by 3. So it's now 9x plus 3y is equal to 12 times 3 would be 36. And I'm just going to rewrite my top equation right above it. So that's x minus 3y is equal to 24. So now do I have the same number but opposites? Yes. So now my y's will cancel. So I'm going to combine my like terms. X plus 9x is what? 10x. The y's cancel. And then 24 plus 36? 60. So 10x is equal to 60. What can I do next? Divide by 10. So x is equal to? X equals 6. So that's one answer. How do I find my y? Plug in 6 into the x. It doesn't matter if you plug it into the top or the bottom equation, but make sure you plug it into x. So I have 6 minus 3y is equal to 24. Now, how do I solve for y? Perfect. Subtract 6 on both sides, so it'll cancel. So negative 3y is equal to, what is 24 minus 6? 18. And then what do I do next? Divide by negative 3. So what does y equal? Negative 6. And how do I write my answer? Positive 6 comma negative 6. Perfect. X comma y. All right, for C, do I have the same number but opposites here? Nope. How can I make them the same number but opposites? Multiply which one by -4? All right, let's multiply the bottom by -4. So everything gets multiplied by -4. So it becomes -16x minus 4y is equal to, what's 13 times -4? -52. All right, and in our first equation, I'm just going to rewrite it on top. So x plus 4y is equal to 22. Which variable is going to cancel here? The 4y's. So what is x minus 16x? -15x, perfect. And then 22 minus 52? -30. So -15x is equal to -30. Now, how do I solve for x? Divide by -15. So it's -30 divided by -15. +2. So x is equal to 2. So that's half my answer. How do I find the other half? Plug the 2 into the x on the top. So this is 2 plus 4y is equal to 22. What can I do to solve for y? Subtract 2. So 4y is equal to 20. Divide by 4. So what does y equal? 5. And how would I write my answer? 2, 5. Awesome. All right, the last page just talks about when to use each type. We are not graphing yet, so you don't have to worry about that one. So you would want to use substitution when one of the variables in one of the equations has a coefficient of 1 or -1. So if it was just x equals or y equals, substitution may be the better option to use. Or you could use elimination when at least one pair of like terms has the same or opposite coefficients. And remember, even if it doesn't have the same or opposite coefficients, we could always multiply to make them the same.